Hello, this is Mr. Brooks, and welcome to Lesson 3.3, Parallel and Perpendicular Lines. In this lesson, we are going to relate parallel and perpendicular lines. The first theorem we will look at in Lesson 3.3 is Theorem 3.9, which states, if two lines are parallel to the same line, then they are parallel to each other. I like to call this theorem transitivity of parallelism. It is simply the transitive property for parallel lines. Stated another way, it would say, if the first line is parallel to the second line, and the second is parallel to the third, then the first is parallel to the third. Our next theorem states, in a plane, if two lines are parallel to the same line, then they are parallel to each other. So if T is perpendicular to M, as you can see in the figure, and T is perpendicular to N, then M and N have to be parallel to each other. Now again, they must all be in the same plane for this to be true. Another way to state this theorem would be, if the first line is perpendicular to the second, and the second line is perpendicular to the third, then the first is parallel to the third. Again, that's if all three lines are in the same plane only. Our last theorem in this lesson states that, again, all three lines have to be in the same plane. And if a line is perpendicular to one of two parallel lines, then it has to be perpendicular to the other. So if we look at the figure, since N is perpendicular to L, and L and M are parallel, then N is perpendicular to M. Stated another way, you could say if the first line is perpendicular to the second, and the second and third are parallel, then the first is perpendicular to the third. We will look at the proof of a couple of these theorems in class, as well as go over some of the examples and the quick checks in class. This concludes Lesson 3.3.